All right. So we're going to take a look. I'm going to share my screen with you one more time, okay? Okay. So we're talking about slope fields, okay? Basically what a slope field or a direction field is it gives us the general shape of a curve, okay? So we can kind of see what the curve is, or predict what the curve is going to look like. We don't know exactly which curve we're back to unless they give us a point, okay? So that is the idea behind what it is. We're gonna sketch only one, okay? And then we're going to work on the other success criteria, and there's only a mere 5 examples today, so this shouldn't really be too bad, hopefully. And then you'll have some time to work. The assignment is actually right there in your notebook, I think. Okay. All right. I don't know why it's being like that either. Oh, good. Okay. All right, so we've got consider the differential equation dy dx equals negative x over 2y. We were supposed to sketch the slope field of the differential equation on the coordinate plane. And then it says we're supposed to sketch a possible solution curve. So if this comes to you on free response, which most likely it won't anymore, but if it does, you only sketch where the dots are. This one has a lot of dots, okay? If there were only like 9 dots, we would only sketch on the 9 dots, okay? All right, so I am just going to start picking values and start plugging in, okay? So I'm going to draw myself a nice little table over here, okay? So I'm going to have the x, I'm going to have the y, and I'm going to have dy dx. So I am going to plug in, I'm going to start with this point right here, 0, 0. Okay? So I'm going to plug 0 in for x, and 0 in for y. What happens with that? It's not 0. Are we allowed to divide by 0? No, so what is it? It's undefined. Technically, something undefined is a vertical, but we usually don't sketch the verticals. I'm going to sketch it on there to actually know what I did with it last year. I did this. I used the yellow because it's like, it's there, but it's not really there. Okay. All right. I'm going to see if I can come up with a pattern, because when I come up with a pattern, I don't have to do all the points, right? Okay, so I'm going to go horizontally and see what happens. So I'm going to choose the point out 1, up 0. So that would give me, I'm plugging into this differential right here. So negative 1 for x, 0 for y. What's going to happen? It's undefined again. So that means, something undefined is a vertical, right? It's a vertical line because that has an undefined slope. All right, let's go one the other direction and see if the same thing happens. Okay, so I'm going to choose to go negative 1, 0. So that's going to be negative 1 over 2 times 0. What do I get? Did I really even need to do that? Could I have recognized the pattern that if we're going horizontally here, that it looks like the pattern repeats itself, right? It has the same slope, at least on that first row. So I know they're all vertical. I'm just going to sketch them in there, okay? All right. We are now going to pick another point, okay? So I'm going to choose to do the point out 0, up 1. So I'm picking this point right here, okay? And it doesn't matter which one I pick. I gotta have to do them all at some point, okay? So I'm going to put in 0 for the x and 1 for the y. What am I going to get off of that one? 0. So I get a 0 slope right here. And that's just a little, remember, we're just drawing little marks for our slope field. All right, I'm going to go down to the negative 1, 0, negative 1. So I'm going to put in 0 for the x and negative 1 for the y. What am I going to get out of it? 0. So could we see that the pattern vertically, all of the vertical ones are going to come out to be that 0 on the top? So I'm just going to go, I'm going to sketch in all my vertical ones. Okay. All right. Now, hopefully it gets more interesting. We'll see. So I'm going to choose this point here, 1, 1. So I'm going to put 1 in for the x and 1 in for the y. Negative 1/2. All right, so I want to go in the negative direction. A 1 slope would look like this. This isn't what goes here, but that's what a 1 slope would look like. So I would go a little bit flatter than that. Okay. All right, I'm going to try to do that whole quadrant and see what happens. Okay. So now I'm going to do the point out 1, up 2. Out 1, up 2. So that's going to be negative 1 over 2 times 2. So what's that going to end up being? Negative 1/4. So it should be flatter than the one I have, but not completely flat. Okay. Let's see what a color have I not done yet. Orange, maybe. All right, I'm going to go out 2, up 1. So 2 in for the x. 1 in for the y. So what's that going to give me? I like negative. Negative 1. So this one was the negative 1 slope. All right, I'm not going to fit my table there anymore, right? So I'm going to move my table a little bit. I'm going to come here. If you didn't write as big as I did, then that's fine. Keep going. All right, and I'm going to do this last one in that corner, and that one is out 2, up 2. So 2, 2. So it'll be negative 2 over 2 times 2, which is going to be what? Be negative 1/2, right? So it looks like it's kind of parallel to that one right there. So it looks like as we're radiating out, it gets more steep, right? As we're going out, if we're going out both to the left and up, it looks like it's getting more steep. I don't know what the pattern is for the other quadrants, so I'm going to go ahead and try the other quadrants and see what happens. I may not do every point. I might base it off of the pattern I see, okay, and see what happens. All right, so I'm going to go back kind of into the inside. So I'm going to go out negative 1, up 1. All right, so I'm putting in negative 1 over 2 times 1. What am I going to get? 1/2. Oh, notice it's positive, so it should be kind of like that, same steepness, but positive 1/2. Let's do one more in here and see if I can follow a pattern, okay? So I am going to choose to do, and it doesn't matter. I'm going to mirror the green one maybe. So out 1, negative 1, up 2. So I'd have negative 1 over 2 times 2. What do I get for that? 1/4. So does it look like we have the same pattern of numbers? It just looks like they're the mirror, or the positive versus the negative. So it's getting flatter here. I'm going to mirror this one here, which was like a negative 1/2, or it's a 1/2. And then the orange one was a 1 slope. It's not hard, it's tedious, right? Especially if I have to do an entire thing. This is 25 points, that's a lot, okay? Typically on an AP test, if I give you one of these and I want you to sketch it, I'm going to give you 6 to 9. Okay, I'm not going to give you the whole thing, okay? Unless the pattern is really, really easy to pick up, okay? All right, let's try this point right here and see if I'm getting something that's close. Then I'm just going to sketch, okay? So it was negative 1, negative 1. All right, so I'm plugging in. I've got negative 1 over 2 times negative 1. What's that going to end up being? Negative 1/2. So isn't this quadrant going to look like this quadrant probably? Or we're going to get mirrors of this one? So it was what? Negative 1/4. And then this one was parallel. And then this one was 1. Or negative 1. All I did was follow the pattern. Okay. All right. Let's go here. Out 1, down 1. So I've got -1 over 2 times -1. So what's that going to be? One half. Okay, so we're going to go 1/2 there. And then again, I'm going to follow the same pattern. We good? Okay, so I'm going to keep following my pattern. I'm going to kind of mirror what I've got in the other quadrants. You know, this is a 1, and then this is it's going to be kind of parallel to that. As long as you have the right shape going, and your slopes are relative to one another, they're correct. They don't have to be perfect, okay? All right, hopefully we recognize slope fields, and we've seen that, and we have sketched before. Okay? All right. Any questions on that one before I move on to the star problems? Okay. This you're going to see on the AP test, guaranteed, and it's going to probably be similar to this. You don't want to have to skip these problems. These are good ones, right? Because we can use process of elimination and figure out which one this is, okay? So a couple of things you want to be careful of. It says shown to the left is a slope field for which of the following differential equations. So we're going to look at the slopes, okay? And determine the slopes on those. Look at the scale of your graph always, okay? Because they may have it scaled weird, all right? I am going to choose to pick some test points and put them in and see if I get the slope out of it that's depicted in the graph, okay? I am seeing this value right here. I'm going to start with that one. I know that it's out 1, up 1. So let's see what happens. Okay, see if I can get some zero slopes out of it. So I am going to test 1, 1. All right, so I get 1 plus 1. What's that equal to? 2. Is that a slope of 2? Couldn't even be described as a slope of 2. I eliminate answer choice A. Okay. I am plugging 1, 1 into my C equation here. What's that equal to? 0. Is that a slope of 0? So that one could be a possibility. Okay. I'm going to come over here to this one. 1, 1. But I had a minus sign in there. What's the slope? Up, so that one gets to stay. What about this other one? All right, so I didn't do a very good job. I got rid of 1. Okay, so I'm going to pick something else. Typically, when we have the signs and the signs are an issue, I want to pick something where it might help my signs flip, okay, and me be able to do something else with it. So I am going to choose to do. Let's try -1, -1. What's that one look like? Oh, it's still a 0 slope, isn't it? What do you want me to do, Tony?
2, 2,
You want me to do 2, 2? Let's try -2, 2. Can we try this one? Yeah, so let's go here. Let's try this 2. So let's go -2, +2. Is everybody good with that? -2, +2. Then I get some sign movement maybe because my signs have become opposite. I've got a negative in there. That might help. Okay. All right, so, and it's definitely, what kind of slope is that, what I circled in red there? Positive or negative? Positive. It's a steep positive slope, right? So I'm looking for a positive number for sure. All right, so I'm plugging in -2, 2. So I've got -2 plus 2. So what's going to happen with my double negative? So what's that going to be equal to? 4. Is 4 a steep positive? Yeah, so that might be my possibility. Okay, that's staying in. I haven't eliminated it yet. Okay. All right, I'm going to put in, let's see, -2 for the x. I'm doing it in my head. -2 for the y, right? Because it was a +2, but there's a negative in the equation. So what do I get there? Ooh, do I get to keep that one? No, that gets eliminated because it's a negative slope. All right, now we're going to do -2 squared minus 2. What's -2 squared? 4 minus 2 is? Ooh, is it a positive slope still? Yeah, so I can't eliminate that one yet. I got to pick something else, okay? But at least I got rid of one more, okay? All right, anybody else got any ideas? -3, -4.
Or like something of that nature, because like we've done one that's like really like almost upright, and then we've done one that's like almost completely horizontal.
So you want to do -3, -4. So this one right here.
Yeah, or something like that.
Okay, let's try that one. What kind of a slope am I getting there? A negative. It looks pretty close to 1, doesn't it? Doesn't mean it is, but I'm definitely getting a negative slope. So I like the fact that we've tilted it a different direction. Okay, so I am now testing. My third test is going to be, we said -3, -4. All right, so I'm plugging that in. I've got -3 minus 4. What happens with this double negative? Cancel, so I end up with -1. That looks pretty good, right? Look, that's about what we predicted it was going to be. All right, so let's test that into this guy here. So that's going to be -3 squared minus -4. What's -3 squared? 9. What happens with my double negative? Positive. Do I even care about the number? What kind of number am I going to get? It's going to be 13, but it's going to be a positive number, isn't it?
Yeah.
So that eliminates D. So it's got to be answer choice C by process of elimination.
This is like my favorite lesson all year.
This is your favorite lesson all year now or last year?
No, this year.
This year, this is now your favorite lesson?
Yeah, I don't get it.
Okay, so what didn't you get?
Well, okay, so the first one we had to get 0, but how did we know we needed 0?
Because I looked at the graph and I looked at that little line and it's definitely horizontal. So I know that the slope there is equal to 0 on that little line. Then I know on this one here, the second one that we picked, it was a positive slope, and it was a fairly steep positive slope, right? And then on this green one, we picked on purpose because it was a negative slope. Does that make sense, Annalisa?
Yeah, I just didn't know how to read the lines.
Yeah, okay. Tony?
Would we ever pick a vertical line?
Sure, you can pick a vertical line because then what's going to happen is going to be undefined, right? Yeah, so it's okay to pick a vertical, yeah. Okay? Are there any other questions? All right, I think we're going to go again. I think it's similar. Let's look at example 3. All right, so I was squishing things in, okay? So this graph here goes to example 3, and this graph here goes to example 4, okay? All right, so the graph below shows a slope field. Oh, wait, we forgot. You know what? We forgot something on the first question, didn't we? I didn't do B on the first one. I know. Let's go back to B on the first one. I just realized I didn't do it when I read this last question. It says that we sketch a possible solution curve to the differential equation that passes through 0, 1. So I'm going to draw that point out 0, up 1. So it's actually this one here that I had sketched already. And then I'm going to just sketch, I just follow the curve. Okay? Yeah, I mean, if they give you guys, if they gave you one, they used to give one for your response like that, and literally all you have to do is sketch through it. When I was in Kansas City grading, and I was grading the awful problem for 5 days, like 4 tables away, I could see their screens, and they were grading a problem that was like that. I was so mad.
Keep your eyes on your own screen.
I know, but I couldn't help it. The guy was standing up, and I literally was at the last table in the room, and I could see all the other 30 tables in front of me.
Well, keep your
So.
eyes on your own screen.
I got bored. I was grading the same problem 500 times. Oh my God! If when
Just like did the roll switch here? What the heck? What the heck?
oh, you want to know who's like mom at home? It's her, not me. I let her do everything, and then I just sit back and yeah. I trained her really, really well. Yeah. Okay. The graph below. So this is it. It reminded me of this. That they reminded me to go do that because this question is asking for the same thing. Okay. The graph below shows the slope field for the function y equals f of x. if the initial condition is 0, 6, what is the range of the solution curve y equals f of x for when x is greater than 0? All right, it isn't exactly the same, but it has some similarity to it. It says it has an initial condition 0, 6. So I'm going to plot that on there, okay? Out 0, up 6 is right here, right? So if I were to kind of sketch along in there, it definitely has some kind of asymptote right there, right? Remember the range is which values? The x's or the y's?
Wait, what? The range?
The range, is it asking about the x values or the y values?
Probably the X. I don't know. The Y one.
It's asking for the y. It already gave you your x's here, right? So this is a goofy question. This is probably not one they're going to ask. It just landed in here to review this, okay? So looking at what I sketched there, right? What's the smallest the y value could be? Look at the graph. What's the smallest y value that I'm going to ever get? It's got to be bigger than 4, right? So our range would be y greater than 4. And I wouldn't even go equal to. I would just go y greater than 4.
Because that's the lowest it can go.
It's the lowest that graph's ever going to go. It looks like it's an asymptote.
It's because it's at constant, it's at a constant rate.
Yeah. Good job. Good vocabulary. Okay. All right. Are we good with example 3? That one was kind of goofy. That's it.
What about the other one?
Other graph.
Okay, the other graph goes to example 4, which we're going to do right now. Okay? All right, so there is supposed to be another answer choice here, by the way. Okay. There's an E that didn't print. There was supposed to be an E, and the E was y equals sine x plus c. Probably, yeah. All right. It's asking us what is the general solution to the differential equation that is generated by the slope field. Okay, so notice they didn't give me the slopes this time. They're actually looking at what graph that is, right? So, first thing I would do is, I would look at the graph and I would kind of look at see if I can eliminate some of the choices. Do you notice how it's a wave?
Yes, it kind of looks like a sine or cosine.
Yeah, it looks like a sine or cosine. In fact, I'm going to go try to sketch. I'm going to try to sketch my wave a little bit. What's wrong with sketching the wave? Okay. All right. So sometimes knowing our parent graphs helps us out a little bit. Okay. So that's the wave that I'm seeing. First of all, and then I would look at my answer choices. So there's one answer choice that immediately eliminates. What immediately eliminates? Look very carefully.
Oh, A.
Why does A immediately eliminate? It's x equals instead of y equals, right? So
That could not be on me.
I would hope not, but I don't know. I didn't write this question, so. Okay. Now I'm trying to determine whether it is a sine graph or a cosine graph, okay? I know when we were in trig, we didn't touch this a lot, okay? So I'm going to remind you, okay? A sine starts at 0, at 0, 0. A cosine at 0 is 1, okay? So let me write down what I just said. Sine starts at y equals, it starts at 0, 0. Let's do it that way. Starts at 0, 0. Cosine starts at 0, 1. Okay? After that, it should go up. Okay? If it goes down, it's the negative sign, okay? Cosine should go down first. We'll look at a cosine graph in a minute just to refresh our memory, okay? All right, so what's going on here? Is it starting at 0, 0, or is it starting at 1, 0? 0, 0. Is it going up first or down first? Up. So it has to be positive sign. If it was going down first, it would be negative sign. Okay? Let's look at really quickly. Let's Let's go to not that button. Let me go to a Desmos tab really quick, okay? Okay. Just so you can see it, Desmos. Okay. All right. Just to refresh our memory, because I know that this is not our strong suit. So there's sine. Looks like just like what we had, right? Y equals negative sine. So notice it went down first instead of up, right? Okay, now I'm going to go cosine, y equals cosine. Okay, I'm going to get rid of my two sines. So cosine starts at 1, goes down first. Okay? Does that make sense on what I'm meaning by up and down? Cosine's easier to tell if it's positive or negative because it'll either be at +1 or at -1. Negative cosine x. So so it either starts at if it starts at +1, it's positive cosine. If it starts at -1, it's negative cosine. Okay? Any questions about recognizing sine and cosine? Okay. Sometimes it's just recognizing the graph. And that's what example 4 was about. Okay? Any questions on example 4? All right, let's take a look at example 5. Okay. Let's see what that one's about. Consider the differential function dy dx equals x squared times y minus 1. Describe all points in the xy plane for which the slopes are positive. Okay. All right, so I am going to do a little bit of guessing and checking here. We need it's wanting positive slope. So I need to figure out where the slope is positive. Okay, so that's asking us where is the slope positive. And again, this one's kind of a weird question. This isn't probably one, it could ask us about this on the AP test. Okay, this is a good conceptual question to make sure we understand what's really going on. Okay, all right, so I want you to, let's figure out what's going to actually affect the slopes. Is it going to be the x value, the y value, or both? So if I were to put any number into x, what am I always going to get out? I'm always going to get a positive. Why am I always going to get a positive? Yeah, so I'm always going to get a positive. So if I put in any number into x, I'm always going to get a positive, except for what number actually? If I put 0 in, it's going to wipe the whole thing out, right? Which isn't, 0 isn't positive or negative. So any number except 0 is going to get me a positive, right? So I know that x is probably not equal to 0, okay? Because I don't want it to wipe it out, because I know that my slopes are positive. All right, let's talk about the y values now. And I'm going to use some test cases, okay? I'm going to pick some values and see what happens with the numbers, okay? Because this is going to determine my entire sign, right?
So why are you not doing that?
Because I already know that my x value is always going to be positive unless it's 0. Okay? All right, let's just go with me for a second, okay? All right, I'm going to start with -1. If I put -1 in for y, that would give me -1 minus 1. What kind of number do I get? -2. So a positive times -2, what's that going to do to the slope? It's going to make the slope negative. All right, that's not good enough, right? So I know I can't use -1. All right, let's see what happens if I put 0 in for y. So I'm experimenting. I'm picking these numbers. Okay, I'm looking for a pattern. So I'm going to go 0 minus 1. I'm plugging it into this. What do I get? -1. So then positive times a -1 is going to make my slope what? Negative. All right, I'm going to put in a 1. So I get 1 minus 1. What's that give me? Ooh, what does that mean about my slope? It's going to be 0, right? Which is still not positive, right? That's 0. 0 is 0. Okay, so I'm going to put in a 2. Okay, so if I do that, I get 2 minus 1, which is 1. So that's positive. Okay. So I know that if I'm 2 or, and I'm going to say something false actually. If I'm 2 or bigger, I am positive. I just said that that's false. What would happen if I put in 1.1? Would I get a positive slope? Yeah, okay. So it's not 2, it's not, y isn't greater than 2, it's greater than what?
1.
Y greater than 1. I don't want to include 1 because 1 makes it 0. But as soon as I am above 1, right, just even a little tiny bit, I know that I've got a positive, okay? All right, so I would probably write a little summary sentence here because it said to describe, right? So the points where x does not equal 0 and y is greater than 1 yield slopes that are positive. That's a fancy word. Yield slopes that are positive.